Welcome to the final video on the first part of chapter 5, so 5a, where we have a particle colliding with a fixed plane. In the previous video we showed you how to use the scalar product to actually calculate the angle of deflection. You could argue really that that wasn't much easier than just using the method I showed you in the previous couple of videos. But here, this is where the scalar product really saves us a lot of time. Here we've got everything given in vector form again. So we have that a small smooth ball of mass 2 kilograms is moving in the xy plane and collides with a smooth fixed vertical wall which contains the line y equals x. So our wall here is at an angle. Okay, this is what makes the question a little bit more complicated. So if I just write down what U and V are first of all. So U is 4i plus 2j. I've drawn that sort of to scale for you. Okay, and our first task is to find the velocity of the ball immediately after the impact. Okay, so here we need to use our scalar product to be able to answer these questions for you. So first of all, we've got to find out what's going on parallel to the wall. So this time it's not as easy because the wall isn't vertical or horizontal. Okay, it's actually at an angle here in the line y equals x. So parallel to the wall, we need to find out what our unit vector is. So we could just say it's in the direction of I plus j, and we divide by the modulus of that to give us a value of 1 in the direction of I plus j, and then we have our unit vector. So from your pure work, you'll know how to do that previously. Now, what we need to try and do is work out the component of this vector in vector form in that direction, and this is where we use our scalar product. So we have the scalar product we need to use to find our multiple of that vector there. We're going to have, we've got 4i plus 2j with our unit vector 1 over root 2 times I plus j. And then if we multiply our dot product by the unit vector, then we'll actually have the value of the horizontal component, or sorry, I say the horizontal component, the component of our vector u that's in parallel to the plane. So I can take the 1 over root 2 on the outside, because that will come into both calculations in a moment, and we've got 4 and then plus 2. So that is the value of our dot product, and we multiply that by 1 over root 2 I plus j, and we're going to have 6 over root 2 times 1 over root 2, which is 6 over 2, which is 3 I plus j. So what that's actually given us is the calculation. If I call this u of x, so if you like, the component that's parallel to our plane, then the value of that from our diagram is what we've found out there. Now the other important one to look at again is perpendicular to the wall, and the unit vector perpendicular to the wall in this case is going to be, because it's travelling in this direction, so if I just call that there uy, so the unit vector in that direction is going to be I minus j, so it's 1 over root 2 of I minus j. So to be able to find out the actual value of this in vector form, again we're going to do the dot product. So we're going to have 4i plus 2j times by 1 over root 2 I minus j, I say times, sorry, that's the dot product, and then we multiply by the unit vector. So again, we're going to have 1 over root 2. This time it's going to be 4 minus 2 times by 1 over root 2 I minus j. So 2 over root 2 times 1 over root 2 is 2 over 2, which cancels out, so we just have I minus j. And that is what equals uy on our diagram. It's worth just checking that it makes sense, so you can see that obviously it's positive I, positive j, and it's a positive I and a negative j, just to make sure you've not made any slip-ups there. Okay, and then we can now work out what our actual components of v are going to be. So if I just go over to green now, so v of x is simply going to equal the same thing, isn't it? So parallel, the speed or velocity before is going to equal the velocity of after. The velocity after, I should say, because obviously the impact is going to be perpendicular to the plane again. So we just know that Vx is going to equal Ux, which we know is 3i plus 3j. And then you've got to be careful again. So with the y component of V, you've got to remember that it's going in the other direction. Okay, now it is a third, so perpendicular, we're going to have that Vy is going to be a third, but instead of I minus j, it's going to be minus I plus j because it rebounds. So again, you've got to be very careful, remembering that, yes, the actual size is going to be a third of the value with which it hit, but remember that it bounces back in the other direction. So instead of being I minus j, we're now looking at minus I plus j. So V, therefore, I've got my two components, and with vectors I just simply add them together. So I've got 3i plus 3j plus a third of minus I plus j. So 3 minus a third of I is going to be 8 thirds of I, and then 3j plus a third of j is going to be plus 10 thirds of j. Now, I've only answered part A because that is the crux of this problem, was what makes it harder than the others. Once you've got that, then I'm sure it's fairly straightforward. We just go on to, as I showed you in the previous examples, how to find kinetic energy and angles of deflection. So that's the new bit that I wanted you to bear in mind, how to use the scalar product when you have things given in vector form, but your fixed plane is at an angle. So good luck with the rest of exercise 5A, and I will see you again soon for 5B. And don't be put off, 5B students have found much easier in the past. We're just using the concept of repeated collisions. So as long as you're clear with your workings, there shouldn't be any problems with the next video. Best of luck, everybody.